Hi guys, Mr. Sonnenberg here. Today we're going to be naming ionic compounds. This is for Science 9 students studying matter and chemical change, and this again is topic 6 in your textbook. We're piggybacking naming molecular compounds and also chemical compounds overview. So today we'll learn how to name these ionic compounds. So what we need to look at is what is an ionic compound. And so we've discussed before that it's a combination of two or more elements. That's what forms a compound. But here we're going to combine a metal and a non-metal. So the left side of the periodic table are our metals, and the right side typically is the non-metals. And we've discussed the periodic table, so we have an idea of where they are. So when we are naming ionic compounds, we're always going to combine a cation, the metal, and so the metal will be known as a cation. We're going to combine it with a nonmetal, and it's going to be known as an anion. So you're going to hear me refer to these two terms, the cation and the anion. So the cation is going to have a positive charge, and the anion we're going to see a negative charge. Now, what we're doing here through these examples is we're going to be combining binary ionic compounds. So if you take a look here at these binary ionic compounds, what that means is that we are combining two different elements. So 2 being the key number here, two different elements. Or also polyatomic ions we'll be adding as well. So the anion, which is right here, okay, the anion, the non-metal, will always end in "ide" unless it's a polyatomic ion, and we'll get to that as well. So if it's not a polyatomic ion, if it's in the non-metals, any anion or non-metal is going to end in "ide." So little rule to follow or remember. So these metals, okay, what happens when there's metals that have more than one cation forming? So if we're forming metals, but they have some of them on the periodic table, and I have one example here, I have iron, has more than one cation. So it has more than one charge. So what we're going to see here is iron 2 ion is actually going to have a 2 plus charge, and iron 3 ion is going to have a 3 plus charge. So now we have two forms of iron ions. So now this is going to be important as we move down. So how we're going to actually write that is we're going to use a Roman numeral in parentheses, and that's going to show its charge. So if I was to write iron, for iron 2, we have these parentheses right here, and we used a Roman numeral to write it. Same thing for iron 3, okay? And these are cations, and we can see that by their positive charge, which we're looking at right there. So that's going to be very important as well. Okay, so what we're looking at here are there are certain metals that are going to have only one type of ionic charge or cation. So the following are going to only have one. So we're looking at group 1A metals. Okay, group 1A metals are going to have a one positive charge, and we don't have to put one positive, we just put the positive sign there, but they're going to be one positive. Group 2A metals are going to be a, I'll write that better, it was a 2 plus charge. Okay, aluminum actually has a 3 plus charge. Zinc has a 2 plus charge. Okay, so zinc has a 2 plus charge. Gold is going to have a 1 plus charge, and scandium is going to have a 3 plus charge. Now these form only one type of cation. Okay, so all group 1A metals, all group 2A metals, aluminum, zinc, gold, and scandium are all going to only form one type of cation. Okay, So that's going to be important. Whereas iron obviously doesn't fit into these categories, so it's going to be considered, or it forms two cations, so we're going to have to use those Roman numerals. For all these metals here, we don't have to use Roman numerals because they only form one type of cation. So how do we find the charge? Well, if you were to look at your periodic table, you're actually going to see there are charges that we can find. So I've just shown a list to just separate this list here. If we look, we can see hydrogen, we can see group 1, so this would be like group 1A metals. Okay, going down, these group 1A metals are going to, remember, they're going to have a 1+ charge. Group 2A metals are going to have a 2+ charge, but then on the other side are anions, okay, which are here, are going to have a negative charge. So we just have to look at the number on the periodic table, and you can actually see, if you look here at this, it has, you can't really see it, but there's a 2+ charge right there. So that's where we have to look. So you can actually find the information on the periodic table. So cations are going to be positive and anions are going to be negative. Now if we look, we're going to actually do a few examples. So I'm going to show you one that we're going to name, and actually I'll show you them all, but it's a good time to maybe pause, maybe even try it yourself, and then see if you can do them as well. So remembering the rules. So what we have here is sodium bromide. So first thing we're going to have, or the first, is our sodium ion. So this is our sodium ion, okay, and our sodium ion has a 1+ charge. Now that's our cation. If we look at our anion, we have the bromide ion, and I wrote bromide because bromide is it's the anion, so I add "ide" to the end of it, and it has a 1- charge. So how we're going to write this, if we're going to name it, we want to have equilibrium, so we want to have the same number of ion charge, so we can actually determine that this is a quality formula and it's balanced. So how are we going to name this? Well, I'm going to call this sodium bromide. Alright, we don't need parentheses because this is sodium is actually one of the metals that only forms one type of cation. So our next example, it becomes a little bit harder, but what we're going to look at here is, first we have our cation. The first is listed metal is always, or the metal is the cation. So what this is it's calcium. It's the calcium ion, and the calcium ion has a 2+ charge. Okay, I'll write that again. 2+ charge. That's a plus sign right there. And then our fluorine, our anion, is fluorine ion. Okay, our fluorine ion actually has a 1- charge. So what happens is, if we look at this subscript, we have two 1- charges, which is going to give us a total of 2 negative, right? If we were to multiply that, because that's the same as 1 negative, okay, right there. So now it's even with our 2+ calcium charge, so we can tell this is a valid formula as well. So now for every 1 calcium we have 2 fluorines, but their ions, their ionic charge is going to be equivalent. So that's very important when we're doing this. Now we're going to make it even more difficult. I'm going to challenge you a bit more. So, oh, sorry, I forgot to actually name this. So this is actually, the name of it's going to be calcium fluoride. oops, sorry, I spelled that wrong. Trying to spell flour. Maybe I should go make some cinnamon buns. Okay, so it's calcium fluoride. So remember, we name the cation first and then the anion second, and the anion is going to end in ide, IDE, except for what we're going to be talking about now, which is polyatomic ions. So what is a polyatomic ion? Well, polyatomic ion is this right here, polyatomic ion. Remember, we talked about them in the last screencast, or in the chemical compound screencast. So what we have here is we have our aluminum cation. Okay, so it's our aluminum ion, and aluminum actually has a 3+ charge. And on the other side we have our anion, so this is called sulfate. This is our polyatomic ion. So sulfate ion. And sulfate actually has a SO4. It has a 2 charge. Now that doesn't add up. So we have to do what's a little bit of math, and I know you guys are going to hate this because we have to do math. Oh no! I always hear you guys complain about the math. So now we have to do some math. So what we need to do is we need to find the lowest common multiple. So what we're going to do is the lowest common multiple is going to be, between the two, is going to be 6. So we're going to make sure we have 6 negative here. Well, our 2 negative charge down here, okay, our 2 negative charge down here, and our 3 subscript is going to give us a 6 negative charge, and then our 3+ charge here and our 2 subscript is actually going to give us a 6 positive charge on the cation side. So this is a valid formula as well. So what we're going to do is we're going to write this out. So its name is going to be aluminum sulfate. Now you're probably wondering, why doesn't it say sulfide? Well, because with the polyatomic ions we use 8 or the ending, whatever ending they have. So in this case we're going to use sulfate. Okay, so we don't need, because of aluminum's nature, being a group 1A metal, or being one of the metals that forms only one cation, we don't have to put any parentheses in here. Okay. Now I'm going to make it even harder, challenge you a little bit more. So what we have here is, we're going to notice that this was not one of the metals. This isn't a group 1A metal, this isn't a group 2A metal, this is an aluminum gold. What we have here is iron. So this is our iron ion. But we're actually not going to look at its charge yet, because it forms 2 cations. So first we're going to actually start by looking at our cation. And I'll talk about these parentheses in a second here as well. But we're going to look at our ion. So our ion is actually phosphate. So this is our phosphate ion. Now phosphate, PO, and it's a polyatomic ion. It actually has a charge of 3 negative. So now we have to determine, we're going to find the lowest common multiple again, just as we did before. So I look at this 3 negative charge down here, and I look at my subscript. So I'm going to say my lowest common multiple is 6 between the 2 and 3 as well, the lowest common multiple. So what I'm going to need here is I'm going to need to make a 6 positive. So which of the 2 irons am I going to use? Well, I'm going to have to use iron 2. So iron 2, so I'm going to actually use the iron with a 2+ charge, because that's actually going to give me this 2, and the subscript 3 are going to give me this 6 positive lowest common multiple. So if I'm going to name this, I need to use the Roman numerals in parentheses, so I'm going to name it iron 2 phosphate. Okay, so just remember some of the rules. Go back, play, pause, rewind. If you have any questions, please bring them to class. But that's naming ionic compounds, so I hope this has helped you. I hope my writing wasn't too messy, and my voice wasn't too nervous for you guys. But anyways, that's naming ionic compounds. Please bring questions to me, and thanks for tuning in. And I hope these really help you guys out. We'll see you guys.